Hi, and this is our extra credit for 202, demoing for one of my friend, and we're gonna introduce us one by one. I'm gonna hold in the camera, so I'm gonna introduce myself first. I'm Shuyan, and
I'm Miraj Patel. Hi.
Hi, I'm Anisha Waghela.
Hi, my name is Femi Haluga.
and this is our guest.
Hello, my name is Ye Yuan. I'm
Yeah.
the guest.
Yes, and we're gonna demo our project to him. Our project is a deep model, and let's start it.
Okay. Here, what basically this project does is converts the Java code into a parser, into a class diagram, and an abstract syntax tree. Let's start with the demo. First, basically, this is a simple class. When we run our program, we get a class diagram for it. Class diagram has its properties as well as methods, constructors, and suppose we want to get inheritance from it, then we can look at the code here. This basically does is a inheritance problem. So we get output. So here basically is vehicle class is being inherited by car class and bike class with an abstract method of these two methods are abstract here.
Oh, I see.
So what do you think about this?
It's cool, but I just want to know how do
Yeah.
you generate the relationship between the classes?
Okay, there is a library called Java parser, and this Java parser library parses the whole Java code which we feed into it and gives us an abstract syntax tree. So we can use this abstract syntax tree to convert it into a relationships in Java, which has been as a Java server, and which it converted it into a plant UML syntax. Plant UML syntax library is another library which converts its syntax into a diagram which is shown here.
Okay, cool. Let's see other diagrams now.
Now this gives us an example of basically associations. Means there are relations between two classes where object of one class of car class is present inside test class. So we have an association present here. So test classes uses the object of car class.
Cool.
And one more example we can look at is relationship between interfaces and classes. Here there is a test interface which is being implemented by the this class. The method test is present in the interface which is implemented by the test class.
Okay.
This was a part of Java parsing and converted into UML diagrams. We also have done conversion to the abstract syntax tree here.
Okay, I see. So you produce a class diagram and a tree diagram at the same time.
Yeah. It is the server is basically we are giving the whole code present in the editor, and the server responds with two objects containing the abstract syntax tree as well as the diagram.
Oh, nice. That's cool.
Yeah, when this structure looks pretty simple, the tree looks simple, but we can go to a more like advanced one. It's gonna be much more complicated. So the tree
Yeah.
diagram gave you like a better overview of the whole structure, and you can also try, edit something. For example, you can add one more like protect variables or one more method. You can try that, and you will see the structure changes. Do you wanna?
Is
try that?
is that changing like dynamic or just?
You have to click run.
Okay.
Not
so
like right after like while you're typing, it's not gonna change.
I'll try
Yeah, you can.
public. Shit. Try to avoid. Just try this thing.
Test.
Yeah, test.
You don't have to do anything. Right. You can run it.
Okay. Run it. Oh shit.
It's not working. Yes. You have just type it.
basically there will be a compiler because it is abstract method. So the classes below has to inherit it, which has not been done. So now, as you see, we have added a new int test. It will be present here. See.
Okay,
This is
so
the-
variables.
Yeah, that's where it comes into variables test. If you add a new method, the new method will be present here.
Okay.
So we can change here and we can see the change in the diagram.
Diagram as well.
Mm-hmm.
As well as the class diagram also is changed accordingly. There is a test variable present here.
Right there.
Yeah.
Okay.
You see it? Right, you see the test we just added, now it's generated to the diagram. And everything is hosted on a IP address.
On AWS.
AWS? Yeah.
Yeah.
Yeah,
So
so,
the way the backend works is that it's running on a Go server, which has the API that this ACE editor calls, and the server. So what we did was to Dockerize to put everything inside a container, so that way anyone can use it if you just do Docker pull. And also we deploy the container on AWS, so you can see that we actually put in from a live IP address. And that IP is actually, because we're using Docker, it makes it scalable, so we can have like 1 million people using it at the same time and it's not going to crash.
And for front end, we are using the ACE editor, and it gives us features like highlighting the syntax. So the features like you can see that blue, the syntax
so
that has been
highlight.
highlighted is a feature that the ACE editor provides. So, and also you have already seen that there is a class diagram tab and the abstract syntax tree diagram tab, and when you run the code you can see the diagrams in the tabs. So that is the UI part.
All right. See.
cool. How do you feel about this demo?
So I think it's really cool, but especially it's like the online compiler and it's working, right?
Yeah.
And you also get some amazing feature like the code highlight, and also generate two diagrams at the same time. I think it's really good.
Cool. Thanks to
Mhm.
let us demo for you, and this is our team. It's
Yeah,
everybody.
Hello.
Yeah. Thank you. See you next time.